Hey everyone, welcome back. So we are moving through the nervous system, and now what we're going to do is we're going to talk about some more of the neurophysiology. So this time we're going to talk about how charges can move across membranes, and they do it. Here's a sneak hint by channels. Spoiler. All right, so it's a little counterintuitive to a lot of folks. So I'm going to try to go over it as best I can. But if you have any questions, feel free to visit me in office hours. All right, let me pick a nice color. Red. Okay, let's get started. Okay, the role of ion channels. So you remember we have right now this axon, right? And so in this axon, we have charges. We have negative usually on this side, this like axon that's just floating around, this interstitial fluid, and it's super negative. Well, it's a magnet and it's going to attract, you got it, positive charges. And so they're going to line up on this outside. And so what's important is, even though we're going to disrupt this to send a signal, is that we're able to rebalance it and fast. Because if you think about it, think about how fast it takes for you to move your arm back and forth really quickly, right? We got to reset that quickly. And so these ion channels are going to help us with that. And they do it a few different ways. Like one of the main ways they do it is they're picky. They're selective, right? Like, so if you're a potassium ion channel, you only want to have potassium flavored ions pass through. That's it. That's your favorite flavor. No others. So there's two main types of ion channels that we're looking at. And the first one are these what we call leaky non-gate. That's kind of like your cat door, right? So potassium ions, think of as about the size of a cat. Like it's small. It can go through a cat door, right? But things like, say, sodium, it's bigger. That's like, your 6'5", 250-pound uncle. He's not going through the cat door. He has to use a regular different door, right? One that's probably gated or locked. So that's just something to think about. Like ions are different sizes. Sodiums are huge and potassiums are so small. They're just tiny, little cat-sized, so small, right? So that's just, one of the concepts to think about. So we have these leaky ones, they're always open. So the potassiums kind of can go in and out as they please for the most part. And they are the ones that are going to bring us to equilibrium. Gated channels, on the other hand, are the ones where we have to physically open and close these channels, right? So it means that the ions that they're letting in and out are heavy hitters. They're big movers, okay? And there's three kinds of locked door or gated channels. Those are ones that have chemical gates, right? Like ligands or neurotransmitters. Others require a change in the outside environment, like a voltage change, like the electricity, or not, that's not accurate. Like the charge gradient around them has to change. Or there's mechanically gated, which just means physically opened and closed, right? So here's a leaky channel. Here's your cat door, right? Teeny tiny potassiums down here. Mechanically gated ones. So here, it's closed until a specific ligand, which is like a key, comes along to open it. Okay. And then there's these ones that just physically have to be opened. Those are mechanically gated channels. Okay. And so those are big ones. Look at those. That's where sodium's moving in and calcium's moving, so those are some pretty big ones, right? These, and then, okay. Right. All right, let's keep going. Here's just a bigger picture of that, right? So, I know these are relative size, but I guess if you were really to see a leakage gated channel over here next to it, it would probably look a little more like, I don't know, that color. Okay. It's right here. It's very small. Really small things can go through it, like potassiums, which are the kitty cats of the ions. All right. So we've got it. So lock and key, chemically get ligand, right? So those are neurotransmitters. Those are the only kind that are opening and closing those. Voltage gate, right? So they need a charge change to happen in the weather outside of that door. When it has a whole bunch of one charge or another, then that's when they open or close. And then there's mechanically gated ones who require that door to be opened and closed physically, right? And so that means we've got to power it up. So we got to pay whoever's going to do it, whichever enzyme, they're going to require ATP, right? So that's like, remember the cash money of the cell. Okay, so if you need someone to stand there and open and close your channel door, you're gonna need to at least tip the doorman there. Okay, door person, door enzyme, doorzyme. I think it would be doorzyme. Okay. All right, so chemically gated and voltage gated. Let's just take a look at these. So here's, okay, right, chemically gated. Remember, this is like the key, right? You require a key here. So in this case, there's a keyhole. We call a keyhole receptor, right? Keyhole equals receptor, right? So for this receptor, that's the only place the key can bind. So here's like an example of a key that actually ended up in the keyhole. And so as you can see, that door just opened wide. There it is. Now everybody gets to pass through, right? So that's the chemically gated. And so the chemical is your neurotransmitter, right? Since it's, voltage gated ions, right? So if you look, like what happens is in this case, we're normal. We're at starting point. So on the inside, S-I-T-E. I don't have a degree in spelling, folks. Sorry. Can only teach you biology. So it's going to be negative, and then the outside is always positive. But when that changes and a whole bunch of negative ions like flow in there, wow, all of a sudden that means that this door just like kind of physically opens up, right? And that's when we're allowed to get that transmission of sodium, and that's going to cause, help to drive that positivity, help to drive it, not exclusively. All right, so when gated channels are open, ions diffuse quickly, meaning ions go through the door, right? Because that makes sense. When you open a door, you're going to go through it. So when the ions have their door, right, that gated channel open, they're going to go through it. So along with like a chemical concentration gradient, it goes from higher to low. So concentration gradient means this. So you remember school, and when you were in school, you would start, here's like the timeline of your education, and right, you start off at kindergarten, and then you go to first grade, and then it's like second grade, and then like third grade, and so on, right? And let's see how many grades you're going to go to, because I didn't draw this to scale. You went to 7th and then to 8th. Looks like you made it to 10th grade. Oh, wait, 8, 10. Oh my gosh. I'm sorry. Get another cup of coffee. Learn how to count. I know my chemistry. Okay, but anyway. So you went to 10th grade in this example. And like let's think of like chemical concentration similar to, like maybe your knowledge concentration. So when you're in kindergarten, they teach you some stuff, and first grade they teach you some more stuff, and then there's some more stuff, and then third grade gets really intense, and then fourth grade, wow, and then fifth grade there's like a lot more stuff, and then by the time you're getting like into high school, the knowledge that you have to know is just so much, it's so concentrated, there's just so much stuff, right, that you have a gradient, okay? And so what we've done here is we've illustrated, yellow, okay. We've illustrated a low gradient here and a high, oops, that was like a terrible color choice. Here we go. High concentration gradient here. So when we talk about chemical concentrations, we go from areas of low or few ions, few bits of knowledge, to areas of, they don't usually like to move into the higher concentrations right away, right? So it's harder to get them to get in there, right? It's easy to get anybody into a kindergarten class, but it's a little harder to push those teenagers all the way through high school, right? So there's like lots of ions, right? So it tends to be that ions love to kind of float downstream. Like they want to go back to when things are easy, okay? And so that's how the concentration gradient operates, right? And it fuels the concept of diffusion. Okay, so wow, that is a big messy slide for me to leave on, but I think what I'm going to do is just kind of like let that sit there. And I just wanted to say thanks for watching, and I hope that kind of clarified things a little bit. I know I have a couple videos out there, but sometimes just explaining things in a new way with new pictures just helps everyone get their heads around it. So I hope you are having a wonderful day.